Perfect. All right, good afternoon, folks. Welcome to today's training session. Yeah, sorry, someone was unmuted and I was getting a lot of feedback. So I'll start that again. Good afternoon, everyone, and welcome to today's afternoon session for Haldex drum brakes. We're going to cover that off. Some quick introductions. My name is Tony Bryan. I'm the Technical Services Manager. If you're looking at the little screen, that big presentation screen, to my right, your left, is Ronnie Hines. He's one of my service guys. We also have in the meeting, we have Kyle Hinton. He's another one of my service guys. He's based out of Kansas City, Missouri. And we also have, I'm not sure if Ben's on as well. Ben, the last of my service guys, is based out of Salt Lake City, Utah. So there's 4 of us here, 2 of us in the room right now. A little housekeeping thing. This is designed to be interactive. So if you have questions, unmute yourself and ask, or you can type in the chat if we're in the middle of something, and we'll try and get them as best we can. Between myself, Ronnie, and Kyle, we'll be able to help you out with all of that. You have to bear with me. I've got a tickly throat, so if I cough every so often, that's why. All right, let's go. So, some quick nerdy stuff. A vehicle is an object in motion. It has energy, and that energy is called kinetic energy. The amount of kinetic energy of an object is based on both weight and speed. So if you double the weight, you double the kinetic energy, and if you double the speed, it's a multiple of 4. The kinetic energy is converted into another type of energy that is called heat, which we know SCAM brakes are a really good generator of heat, as you all know through working in this industry. So the heat is generated through friction between the drum and the shoe. The lining's coefficient of friction varies based on both brake temperature and surface conditions, and the heat is dissipated through the brake drum. This means the drum not only helps create the friction, but also acts as a heat sink. So I'm sure most of you in this industry should know the basics by now, but in case you're fairly new and trying to learn, we'll just quickly run through the brake assembly. The components are a brake chamber, the push rod attached to a clevis and pin, the slack adjuster, the yellow part is the SCAM, and then you've got the brake lining and the brake drum. They're the major components of it. Now, this particular equation, you don't have to remember any of this. There's no test at the end. So, but we're going to run through this. We'll run through some changes to this later on, just to give you an idea of what happens. But from left to right, you've got your air pressure, 60 psi, your brake actuator area. So for those of you who don't know, a 30-30, the number 30 is 30 square inches of surface area on the diaphragm. Okay, so the first number is always the service brake, the last number is the park brake. So a 30-30 has a 30 service brake and a 30 park brake. Okay, for the braking force, you're generally trying to equate what's in the service side, unless you're doing a park brake equation. The next number is 6, is the slack adjuster length, 6 inches. Shoe leverage, friction, drum radius. Then you've got tire rolling radius and cam radius. And that will all mash together, gives you a brake force. And we'll touch on this a little later on to show you what some changes do to this equation. Okay, so brake chambers, we have 2 types of brake chambers, service brake and the double diaphragm. So basically service brake you'll see on a steer axle, or even on a trailer you'll see it on a self-steer axle. It's not so common that you will see it on a rigid axle anymore. You don't need to, just for commonality of parts. And then a double diaphragm has the park brake side on the end, and that's generally used on drive axles and trailer axles. So what goes into making a brake chamber? You've got the actuator rod, otherwise known as a push rod. You've got the diaphragm. You've got the return spring, the band clamp, which is the yellow part in that. And then you've got the stud housing, the front mounting plate. and you've got the rear pressure cap where you've got two fittings out of that pressure plate. They both go to the same place. It's just whatever fitting is more convenient for your application, so it doesn't foul. Okay, so you'll generally see one of those two will have a plug in it. Then when you get to a double diaphragm brake chamber, you'll have the same thing until you get to the centerpiece. You'll have this big aluminum center housing, center body here. You've got a center seal in here, okay, a return spring, diaphragm, a piston assembly in here. You've got the release bolt, caging bolt, whatever you want to call it, same thing. And then you've got the park brake spring here and then the housing. So a couple of things you'll see here, worth note is the front will have a band clamp on it. The rear nowadays is generally crimped like this, so they're tamper resistant. You can't actually get into it. That's because that spring has a whole lot of force behind that, and too many people were under with band clamps, and this was taking off and causing injuries or worse. So nowadays you can pretty much see everything in the industry will be crimped like this, so you can't get into it. The other thing you will see in there, just a little air brake thing, is when you're releasing your park brakes, this cavity is full of air. If you ever get a leaking brake chamber, leaking, you can sometimes see them leak through these O-rings. It will actually then bleed out the service side. So if you've got a constant air leak when the brakes are released out of the exhaust of the relay or ABS valve port, that's go looking for the root cause. It's probably a leaky brake chamber. This will generally propagate itself. You'll have wear on all wheels attached to that relay valve, but it'll quite often be worse on that one wheel end that is actually got the leaky seal on it. All right, some spring brake identification tips. These two brake chambers are basically the same, but there's one subtle difference. And no, it's not the slightly different colored band clamp. It is the ports that are on there. So you'll see on the left, they are round ports. On the right, they are square ports. That means the left-hand round ports are standard stroke or short stroke, and the square are the long stroke. So that's one of the identifiers mentioned, and that's controlled by the SAE, Society of Automotive Engineers. That's one of their recommendations on how to tell a long stroke. Another way that you'll see is these red plastic clamps that go around one of the fittings. That will tell you it's a 3-inch stroke or a long stroke, and then the standard 2.5-inch stroke won't have that. So there's a couple of different ways. I think there's one other way that basically never gets used as well. So, but they're the two main ways you will actually see out in the field. All right, double diaphragm chamber. If you've got one that won't hold on hills or it's dragging brakes or something weird and wacky in there, give the back end of the brake chamber a shake. And if you hear a rattling noise, you've probably broken a park brake spring. So what can happen if you get moisture ingress into the back end of the park brake chamber? It will allow moisture and corrosion to start in there. If you've got some coil clash, some spring clash, two of those coils actually rub each other, they'll rub the coating off, and that will just accelerate that issue. And with the corrosion that happens after that coating is rubbed off, you'll eventually break a spring. If you're lucky, it'll break the spring and it will rattle around. If you're really unlucky, one of those two broken ends will actually pierce the diaphragm, and you'll have an air leak, which is a really easy find because you've generally got holes around the brake chamber. You'll be able to hear that very easily. All right, so these two pictures on the right-hand side there, that's just corrosion that's happened on those. That's very lucky that those haven't gone off yet. That spring in there, you would hope that spring's broken because that housing on the back end is ready to let go at any moment. So that's something you really don't want to see going forward, but you need to be very careful when you're taking those off because there's not much meat left on that housing to hold that park brake spring in there. So the picture on the left-hand side there, the release bolt piston looks fairly centered in that hole. If it's off-centered, that can be an issue. But in this case, it looks like the spring is broken and part of it has actually come across that hole and covered up the piston. So that brake chamber, if you haven't already broken the diaphragm open to lose all the air, it will be trying to push back on that park brake spring, but it won't go any further out because that park brake spring is actually fouling up on the piston inside there. All right, some applications. This is what it would look like from the inside. So the light blue part inside that brake chamber signifies what's got air pressure in it. So like always, we're going to color code these blue as you would do for your service brakes on your blue glad hands on trailers, and then red is your red glad hand or the park supply side for trailers and trucks as well. So you push the dash valve down, you've got park brake air pressure going into your brake chambers, and it's air pressure the back half of the chamber up, it's pushed the diaphragm back, and it's compressed that park brake spring up. You've also put your foot on the foot valve or the treadle valve, depending on how old you are, what vernacular you want to use, and that's put air pressure in the front half. So that's actually then pushed the push rod forward. So this is what you would see if a truck was stopped at a set of traffic lights. Park brake is released, but the foot valve and service brakes are applied. When it's parked, there's no pressure in either side of the brake chamber, and the park spring pushes the whole chamber and push rod forward, and that is parked on the park brake spring, so there's no air pressure on there at all. In this particular case, you've got the park brake spring applied, driver jumps in the cabin and hits the foot valve, and you've got air pressure going into the foot valve side of the chamber. So you've not only got the spring force, but you've also got air pressure in the front half pushing as well on top of that. So that's what's called compounding the brakes. This one shows it being compounded. And then there's a function called anti-compounding. Essentially, it's a double check valve. So you can see from the right-hand side, the dash valve, there's no air pressure in that red line. You put your foot on the foot valve, it's gone through the blue line into the front service side of the brake chamber. And there's a double check valve that goes through, and it's using that same pressure from the foot valve, service pressure, and not only putting it in the service side, it's also putting it into the park side of the brake chamber, just to try and take the pressure off that park brake spring. For those of you who don't know, a double check valve is a very simple valve. It's 2 ins, 1 out, and the highest of the 2 ins wins. So in this case, you've got no pressure from the red dash valve, but you have pressure from the foot valve. It's going to win, and it's just going to share that pressure from the foot valve into both sides of that brake chamber. If you're familiar with the spring brake valves out there, there's some out there that have the anti-compounding feature built into it. If you're using valves other than the Haldex one, some of the more familiar ones are the Silco valve or the Bendix SR valve series. If you actually look at the SR valve series, you'll see on the back end a little bit of the square plate that sits on the back. It's a double check valve. That's all it is. So you'll be able to look at that very quickly. That's all it is. If you don't have one like that, you can very quickly use a double check valve, and it'll do the same job. All right, I mentioned about the brake calculation. In this case, what we're going to do is we're going to change a 30-30 to a 24-30. So the service side has changed to a type 24. That's 6 square inches less of surface area. Less surface area equals less force. In this case, you can see here, you've actually lost about 20% of your overall brake calculation just by changing the brake chamber from a 30-30 to a 24-30. So that's going to mean a couple of things. If it happens to ever be on a steer axle, you're going to have torque steer. If it happens to be on rigid, you'll have mismatched braking, and you'll also have uneven brake wear because you've got different brake forces on both wheel ends. So having a will-fit brake chamber of different sizes, will it bolt up? Yep. Will it work? Yep. Will it cause you issues? Absolutely. So it is not the right thing to do. It's also a DOT violation as well. So think of that when you're mixing and matching brake chambers. It's a no-no. You shouldn't do it. Also, your slack adjusters. So your slack adjuster measurement is from the center of the S-cam to the center of the pin. the yoke pin, clevis pin, whatever you want to call it, on the left-hand side picture there, you can see there it is, whether it's 5.5, 6, they're the two common ones, but I've seen everything from 5 to 7 inches in half-inch increments. So just measure that. That's part of your calculation. So if you're replacing your slack, just go and make sure that you're using one that's the same length. The other thing is, if you're mounting a brake chamber, measure the slack adjuster so you know which holes to put it in. So you'll see on the picture on the right, the top holes are for a 5-inch slack, the bottom holes are for a 6-inch slack, and if you put diagonally across the green line, it's a 5.5-inch slack adjuster. Okay, so always make sure that you measure the slack and the holes and make sure they're in the right spot. Okay, so this one here, this shows a 6-inch slack. And then you've got a 5.5-inch slack on the right-hand side there. One other thing I did notice in this photo, the picture on the right-hand side, it has a yoke or a clevis, whatever you want to call them, from a different slack adjuster. You can see there's a second set of pins there for that hole. That's more than likely it's off a another style of slack adjuster. There's two types of slacks. One will mount to the axle to get its automatic adjustment. So there'll be a bolt or a bracket or some form to get its automatic adjustment. The other style has up the arm of the slack. There'll be another rod that will sit up here. And as this angles over forward and backwards, that rod will be pushed up and down. And that is how you get your adjustment. And that's what the second pinholes are for. So in this one, the steer axle has 6-inch adjusters, and the drive has 5.5-inch. So just remember, check your slack adjuster lengths, make sure they're the same, and you're not going to have issues going forward. So what happens if you mount the brake chamber in the wrong hole for the slack, or you change the slack to the wrong size and you don't change the brake chamber into the right holes? You're actually going to pull the push rod into a place where it should belong. You can see on the left-hand side there, that push rod is now rubbing on the housing and wearing through that housing on the mounting plate of the brake chamber. That probably won't make a huge amount of difference in the short term to the brake chamber. It may eventually move the push rod all the way over and that may cause issues, but the short-term issue you're going to have is it will more than likely wear into the push rod, which will increase the chances of you bending the push rod, which will then cause other issues as well. Okay, so just keeping that in mind when you're fitting slacks and brake chambers. So in this particular case, we're going to change one more thing. We've gone back to 30/30s all round, and we're going to change the slack adjuster setting. We're changing from 6 to 5.5-inch, and in this case, you're going to lose about 10% of your force output. So you can see the numbers change there, and the only variance is the slack adjuster. Okay, again, that's a DOT violation, so just make sure that you have the same size slack across the board. The stroke indicator, so if you see these red marks come out of the push rod, out of the brake chamber, that's a stroke indicator to say that you are over stroke. Okay, so just make sure if you see that, that's bad, go and have a look. What's happened? What's wrong? Is your slack adjuster not adjusting up correctly? Is something fouled? Something's not right in there. Okay. And you're able to double check your legal limits of travel. We use a type 30 as a guideline going forward because there's a couple of slides on this. So your available stroke is 2.5 inches. Your maximum readjustable stroke is 2 inches. Okay. And if you see this one, you see all of the little red marker on the push rod come out. Okay, that means that there's no more brakes left. Whatever braking force you've got, that's it. You've hit the end of the travel in the brake chamber. So you can have 20, 50%, 90% brakes, whatever you've got, but that's it. You can hit the pedal harder, it's not going to change anything. You run out of stroke on that brake chamber. And if you actually look at the force output graph on a brake chamber, it's the very last little bit of that graph where the force output actually drops off. So you've actually lost force by stroking it that far. When replacing brake chambers with cut to length push rods, we recommend you identify the brake adjuster that is being used and follow the brake adjuster manufacturer's recommendations for the procedure. And that way you'll make sure you get it right, because every manufacturer has a different way of doing it. Some have templates, some have lengths that you can use, some have measurements you can use, etc. So make sure you are following the proper procedure to get the correct adjustment so everything's working as it should. In the case of Haldex, whether you're using the AA1 or the Saba slack adjusters, there's a document that we have, which is actually a couple of slides on, L26001, that tells you a whole procedure on how to cut them. And I'm not going to run through every step on that. But Mark 1 is from center of the S-cam up to the push rod. That's basically 90 degrees. And then you measure Mark 2, and your cut mark is a combination of the stroke and your clevis. So you're going to measure from the center of the pin of the clevis to the end of the thread where it's going to poke through into the clevis. And that measurement there is what you're going to mark as one of the marks in there. So, all right, so this one here, a little bit further, there's an extra column to what we saw before. Available stroke on a 30 is 2.5, readjustable strokes 2.5, 2 inches, and then setup stroke is 1.5 inches. So when you're setting these up, these are just little things to make sure that you get everything correct. This is the document I mentioned about. It's a little 2-page document. Just shows you how the whole procedure, which, like I said, in the interest of time, I'm not going to go through every step, but it mentions every step, what you've got to do, easily downloadable on the website. We are going to try, before we send this out to everyone, we'll try and update that literature number to a link, so you'll be able to click on it. And I think I did forget to mention at the start of the presentation, we are going to send out this, and yesterday's morning session, we are going to send out this presentation as a PDF, so you'll be able to get it and click on links. And we are going to send out the recordings of both sessions so you can watch them back. Just make sure if you want to add them to your LMS, your learning management system, or your internal system, download the videos, because they're only shared for, I think it's a month. All right, 2 types of slack adjusters that Haldex does. The AA1 and the Saba. So you'll notice on these, there's 2 different mounting types, which we'll cover off shortly. They're both basically mounted to the axle in some way, shape, or form. Unlike some of the other pushrod versions, such as the Bendix and Meritor style. I'm not going to go too deep in the weeds of the operation, just for the interest of time. But this will give you a bit of an idea of what's inside it. Whether you've got the worm drive, the clutch, the gears, etc., what's in there, and the little adjustment heads that's on the end, and that will give you an idea on how the slack actually works itself, of what's on the inside of it. Brake adjuster procedure. This is a full procedure on how to set a brake adjuster from Haldex. One of the big things that I do want you to remember is that the slack adjuster should be central to the pushrod and to the yoke clevis that it's going to attach to. You can see both of these are offset. So that means that when you get washers on either side of that slack adjuster, you've got too many on the inside of it, or on the right hand side of this picture. So you're probably going to have to pull the snap ring off, pull the slacks off, and the washers off, and start repacking it from the other side, and just adjust that till it's central. All right, positioning of the control arm for the Saba slack adjusters. We do recommend that when you're doing multiples of these, make sure they're all the same. Just make life easier for the next technician. Otherwise, if you've got all 3 on one trailer are centered and one's right at the end, that technician might go, well, has this moved? Is it loose? Has something happened? What do I need to do? The last thing you want to do as a technician is chase your tail, trying to find something just because the previous technician was lazy and didn't do it correctly. So make sure they're all common between all the slack adjusters. On the AA1, it's a little easier because you've got the installation indicator on the slack. And this one, I will bring one thing to your attention. These little black plastic grommets that are in there, when you're doing your PMs, just make sure these are in there. They haven't moved, nothing's weird and wacky with these. I have seen a scenario I'll give you. When I worked back in Australia, we had an extreme duty cycle vehicle with roll stability. It was a tanker picking up milk from farms, and it was hitting a lot of potholes. So high center of gravity, movable load, lots of potholes, and the roll stability was activating in an extremely aggressive fashion. Because it was actuating so often, those little plastic grommets were all missing. And so what we want you to do is just do a quick visual inspection while you're under there doing a PM inspection, make sure they're all still there. All right, so mounting styles. Most of these are a variant of the flat anchor pin style that you'll see in there, or they anchor in some way, shape, or form, but these are all the different style of brackets you might see out in the wild. Adjustment. Most people know a drum brake adjustment by now. It's fairly universal across all brands, but it's literally adjusted up until it hits the drum, and then you back it off half the turn. It's very similar if you've ever played with disc brakes. You will do exactly the same thing. You'll adjust the caliper up until the pads hit the rotor, and then you'll back it off a certain amount of clicks based on the manufacturer. Some are 2, some are 3, but generally it's very similar procedure. A couple of things here. We recommend using a manual greaser. Don't use a air operated one that's connected to shop air, because that is way too high a pressure. If you are going to use a shop air pressure, make sure there's a regulator in there to regulate it down to a decent pressure. You don't want high pressures, because the last thing you want to do is blow the insides of the slack adjuster to its outsides, and then you have a slack adjuster that doesn't work. The other thing is, don't use moly disulfide grease. Moly grease is much easier to say. That can cause a couple of different issues. I've seen issues where it can cause the clutch to slip. I've also had a recent scenario where something in the manufacturer that supplied the moly grease to a customer, it actually destroyed the clutch mechanism. There was some compound within the moly grease that was destroying the clutch mechanism. Unfortunately, in that particular case, we bought gunite slacks within the last year, and these were gunite slack adjusters, but they were made by the previous manufacturer. So that had to go back through them as a claim, but it certainly wasn't a manufacturing issue by us or even by the previous manufacturer. It was actually a grease issue from the grease supplier. So a fleet unfortunately listened to some bad advice from a grease supplier and said this will do, when that certainly was not the case.
Can you ask a question about what's the difference in 26 series?
Kyle, you want to take that one?
So yes, I think David asked a question in there. What's the difference between the 20 and 26 series brake adjusters? So this is actually specific to the Saba series adjusters, and this is something that you would notice if you're looking on the side plate on the part number. All of our part numbers for adjusters typically start out 409, and then it's either going to be followed by 10 if it's a AA1, or 20 or 26 if it's a Saba. The difference between the 20 and 26 series basically has to do with how much free stroke a wheel end is going to have once you get the adjuster set up. The kind of jumping ahead a little bit, but Tony will talk about it. Reduced stop distance, when that became a thing starting back in 2011, the friction materials got way more aggressive, and we started to see a phenomenon, what we call green swell, where after you install a new set of shoes and they go through a handful of heat cycles to get burnished in, they actually grow in size. So the 26 series is kind of optimized for that. It is normal to see those with anywhere between 1/2 and 3/4 of an inch of free stroke to basically allow that shoe to swell up and not cause the brake shoes to drag on the drum. And then the type 20, those ones they're kind of right there. They run a really tight ship. So normally you're going to see anywhere between 7/16 and 5/8 of an inch of free stroke with those. But they are completely interchangeable. It is something that you would notice whenever you're going through, if you're measuring brake strokes, if you see one that has a little bit longer free stroke and a little bit longer applied stroke, that could be something to look for. See if there's a 2.0 on one side and a 2.6 on the other. And as long as you're meeting the brake stroke, or you're below the brake stroke minimums set forth by DOT and everything, you're just fine.
Thanks, Kyle. All right, and again, just a reminder, this is purely interactive, so if you do have a question, feel free to ask, and we'll do the best we can to answer it. By the way, between Ronnie, myself, and Kyle, we'll should be able to answer any questions you've got. All right, so how often should you adjust an automatic brake adjuster? We get asked this all the time. All right, if you're installing new components or doing a brake job, absolutely, yes, you'll do that. That's how you get your correct running clearance from your shoes to your drum. But if a driver says the brakes need adjusting, no, that's not correct. They should not be requesting a slack adjuster to be adjusted. If they think something is loose or something's not right, then go and have a look. Could it be the slack adjuster not adjusting up if it's failed or something like that? Yes, possibly. But more than likely there's something else more sinister in there. So it's an indicator, whatever the driver complaint is, but it doesn't mean that it needs adjusting. They're automatic slack adjusters, so it should do everything itself. Unless the automatic part of it's not working, and then that's something you've got to have a look at. But if it's an automatic slack adjuster and they say it needs adjusting, then either the automatic's not working or something else is wrong. So things to go look at the anchor bracket and control arm. So as you can see in the bottom of this image down here, clever spin and bushing. I've actually seen the bushing missing in the past. Clutch torque, again, polysulfide grease, and then operational performance. What do we mean by operational performance? So you can do a slack adjuster operational check. If you've ever done one on disc brakes, it's almost identical to doing these. Back the adjuster off one full turn, and you can just check the torque, see how much it takes to actually turn that around, and then apply and release the brakes. And what you'll see is the wrench will adjust on release. So what you're looking for is for it to move and not come back. If it doesn't move, or it moves and comes back, you've got an issue. This is almost identical to doing it to disc brakes, same sort of deal. It's a little hard on four-wheel ends to see it, whether it's a tandem drive or tandem axle trailer. Easiest way, and it's the way I do it in the field, is I'll use 2 wrenches down one side, apply and release the brakes, and watch them move in tandem. And that will very quickly identify if you've got one issue on one wheel end, and then grab those same wrenches, flip them to the other side, do the same test the second time. It's very easy to watch straight down the line and watch 2 wrenches turn at the same time. Watching 4, it's pretty impossible to do. So measuring brake stroke, you have 3 separate measurements. You have A, which is fully retracted, B, which is your drum contact using a lever, and then you've got C, which is brake application between 90 and 100 psi. So A to B is what is called free stroke, and then A to C, which is the brake application with 90 to 100 psi, that is your applied stroke. So they're the 2 measurements that you will hear people refer to commonly, whether it's free stroke or applied stroke. You will actually get 2 different measurements from here. Observed apply stroke measurement with a 30 chamber and 3 stroke. That one's just a tad over 2.5 inches. Easiest way to do this, as you can see there, is the cable tie push rod. Pretty simple, very inexpensive to do. Something else you might see out there is when someone's complaining, like a driver complains that the slack adjuster needs adjusting. go and check the bushing in the S-cam. Check for free play in that bushing. And that will be one of the things that will contribute to overstroke and loss of brake force eventually. And while you're checking that, the radial play, we'll mention that as well. It should be replaced if it's over 60 thou end play in that S-cam bushing. And while you're there, just check for any corrosion, cracks, basically anything missing, bent, broken, the usual suspects. This one here is just what it looks like on the inside, the bushing and the seals. You'll see the seals facing inwards for grease relief. So when you over pressurize that, you're putting grease in there. Eventually, it'll get to a point where, okay, I'm going to wipe myself past the seals, and the grease will start to come out. That's when you know they're fully greased and ready to go. In proper wear pattern, in this particular case, the top shoe looks almost brand new. The bottom shoe is right on or well past. It's the minimum wear on a brake shoe lining. So what could be the cause of this? Broken return spring, weak return spring, something like that. I did see one recently that I will mention. Both shoes are actually worn evenly. However, the photos that we were sent by the customer showed the top shoe had significant clearance, probably about half an inch from memory, and the bottom shoe was sitting on the drum and it was parked on the bottom shoe. So my first thought was it's missing a roller, it's missing an anchor pin, something significantly wrong here. I actually got there and it was none of the above. It was one of those magical little unicorn moments that you never get the opportunity to see. If some of you have heard the term, and I'll go to the next slide because it'll give you a bit of an idea. If you've ever heard the term cam over, so when your shoes are worn enough, instead of stopping and parking here, the cam will rotate further and further and further. Eventually the linings will wear enough and the roller will actually jump over the end of the cam onto the other side. This one was a little unicorn moment where normally they'll both jump over the S-cam at almost exactly at the same time. This one had jumped over and the other one hadn't quite done it yet. So both rollers were on the same side of the S-cam. So it was one of those weird little moments you never get to see in real life, and we were actually lucky enough to see it and have photographic evidence of it as well. But in this particular side, you'll see the red circled areas. They will show that the roller is sliding against the head of the S-cam and it's caused a flat spot. If you see this, replace the S-cam because it's just going to find it over and over again. And a little bonus points, if anyone else has noticed anything wrong with those pictures, what is wrong with them? If you have a look at the roller in both of those photos, there's nothing holding the roller in place. There's no roller retainer spring, or even in some cases they'll use those bolt-on style rollers, bolt through the hole. There's nothing actually holding that roller in place. It's just free floating in there. So that is definitely not how it should look. All right, this one, we're looking at a bent brake spider or cam bracket or brake chamber mounting bracket. You can see here on the right-hand side of that, the back end of the trailer, the brake chamber is nice and square or where it should be. On the left-hand side, that brake chamber is all skewed. You can see it's been replaced because it's way less dirty than the one on the right-hand side. And so whatever hit that to damage the previous brake chamber is actually, I'm guessing it bent a bracket of some description in there. And the mechanic who fixed it literally just bolted a new brake chamber on and didn't give it the due diligence it should. So something is bent and he's probably going to have issues there going forward. And also marries up with whatever it hit. I just realized it's also got a brand new tail light on the left hand side too. So whatever it hit certainly caused some damage there. All right, some improper wear patterns. This one here could be a bent brake spider, twisted brake shoe, your wrong shoes for the application. Don't laugh, I've seen people try and put 8 and 5/8 mountain brakes on a 7-inch brake, and then wonder why certain don't fit, or the drum hangs out the inside of the, or the shoe hangs out the inside of the drum. This one here, brake spider, most trailer brake spiders are actually welded to the axle. The bolt-on style seems to be fairly unique to the truck market. It just gives them some extra tools that they can use as far as rotating this brake shoe around somewhere, so it's not going to foul on all sorts of things. There's a lot more on a truck drive axle than there is on a trailer axle that you have to make sure you've got clearance on. Noisy or squeaky brakes could be all sorts of things, from loose rivets, S-cam bushings, rollers, return springs, anchor pins, loose bolts, all sorts of things. Also on a trailer axle seems to be more prevalent on spring suspensions, because on air suspensions, the trailing arm tells you which way around the axle goes. But on spring suspensions, it's possible you could get an axle and actually mount it back to front. And so if you've ever seen a trailer or a truck reverse and brake, and you hear the brakes squeal and carry on, that's basically what happens if you put an axle against rotation. So imagine putting that whole axle back to front when it drives forward. That's how it's going to brake. So there is a set correlation between the axle rotation and the way the S-cam works. So make sure that they aren't against rotation. Other wear patterns. Let's have a look at some of the weird and wonderful wear patterns we're going to look at. Okay, so this one, shoe and table separation. This one, quite simply, is what's called rust jacking. If those of you who don't know what rust jacking is, brakes generally generate heat, as we've already covered. The heat draws in any moisture. If that moisture happens to get between the shoe table and the friction material, that will then start the corrosion process. That corrosion will then grow and push the linings up and out, and that's what causes rust jacking on those friction material. And the friction material will give way before the steel table on the brake shoe will give way. So that's why you end up with cracked friction material like you're looking at there. Improper wear patterns. All right, bad drum, poor bearing adjustment. So if you see bearing adjustment would generally be the bottom shoe will have inside wear and the outside shoe may have the top shoe may have outside wear, something like that. That could be for bearing adjustment, and the hub and the drum and everything is skewed over. So always think about those as well. This is what you're looking at. This is what most preset bearings are nowadays. They're a little bit different to the old school end play where you had to do 100 foot-pounds, back them off a few times, and then do 200 foot-pounds and set those as they should be. Nowadays, a lot of wheel ends are preset bearings. They have that spacer between the bearings, and as a result, there's no end play adjustment. You literally just crank it to a taut and it's set again. Okay. All right, bell mouth drum. This is an interesting one here. So this is what a bell mouth or what the shoe would look like. Okay, and then in this particular case, what's going to happen is the drum has got hot, like all metal. When it gets hot, it expands. So it expands radially, opens up this way, and you see the contact point on the shoe making contact on the inside, and then on the outside, it's not making contact. The result of that is the shoe's going to want to try and follow the drum. So two things will happen here. Well, three things actually. You'll have some slight inside wear here. The other thing is, because of this, it's trying to push the shoe outwards towards the open end of the drum. On some drum brakes, you'll have, well, on all drum brakes, you'll have a washer of some description between the brake spider and the S-cam head. On our SAF-HOLLAND trailer axles that we do away with that washer, and we put what we call a wing plate in its place. So it's basically an overgrown washer that looks like a big, almost a rectangular plate with a little bent wing on the end of it. What that does is that keeps the roller from moving away. It means that as the drum expands and pushes the shoe inboard, it can't push that roller off the S-cam head. It literally, that wing plate pushes it back into place. So if you've ever seen a roller off the end of an S-cam, this is more likely the cause. Okay. And then the other cause that you will see here, it will actually end up causing an issue with extended pushrod travel, which then messes up with your adjuster function on the slack. So what happens when this is hot, it's adjusting up based on that hot brake, but then it cools down and everything shrinks and you've got very tight brakes. Another one is scored drum. You see these a lot in off-road use, from road debris, sand in between brakes. Just acts, very coarse and just grinds away grooves in the drum. It does also happen on disc brakes on the inside of the rotor as well. But another one is where the rivet holes are on a brake shoe. Obviously, there's no material in those holes, so it doesn't wear as fast. So you'll see the grooves all tend to coincide with those 4 rows of holes that hold the friction material lining to the brake shoe. And I'll mention later on about reduced stopping distance, but you'll notice that about a little over a decade ago, the RSD laws came in and you went from 2 sets of shoes to a drum to 1 to 1. That's because of a change in friction material, because they had to meet those laws. It means that the friction material is a little bit more aggressive. So that's why that change is there. But you used to have to machine drums every time you did a brake job. If you didn't, you had grooves in the drum, and this is what it looked like. And then you would have uneven pressure across the shoes and you would crack the line. And then on a couple of different lining types. So this is a tapered lining type. So you've got an anchor pin on the left-hand side, you've got a roller on the right-hand side. So you notice the left-hand side of the lining is thinner, and then from the middle part to the end is the thickest part, to the right-hand side there. Okay. And then on this one, when you completely wear it, you'll end up with, it should be even by the end of its wear life, unless something weird has happened. Then you'll notice that it's hit basically the wear limit, which is that step in the side of the shoe. You'll see that, and that's an even wear across the board. That still will be changed. And then on the Eaton shoe, these are a single anchor pin style. It's not tapered. This is what a new shoe looks like. The highest part is in the middle. And then when they're evenly worn, you'll notice the lowest part is in the middle. Okay. That's because they move at both ends. So glazed linings on your shoes or your drums. This one here, if you are glazing them over, you can clean up the drums. You could machine them, or you could emery paper or something like that. But that's generally an issue. You're dealing with a wheel end issue. So go and have a look at the root cause as to why it's just doing it on one wheel end. But it could be underwork, low heat, wrong linings for the application. We've seen that before. Another one you'll see is missing chunks of material. This one has probably seen a significant heat cycle and it's baked the resin out of it, and that's why it looks dry and powdery and that chunk is missing. Okay, so always have a look at that as well. And then a cooked lining generally look white in color like this picture. It could be brake fade, brake imbalance. The drum could be warped, brakes not fully released, airlines restricted. So you're applying very slowly, but you'll release even more slowly while you're trying to take off. And then you could have lubricant contamination on there, which will burn itself off if it's not significant. And as always, if you do get a significant wheel end leak, you're supposed to, if you get grease or oil onto your shoes, they should be replaced. So what goes into the friction material? Obviously, they've changed over the last 10 years or so based on the RSD laws that came in, which is we'll get to in the next slide. But these are just some of the things that go into the friction material. And the friction materials are actually different between drum brakes and disc brakes. On the disc brakes, there was also a different change come through over the last 5 years. From 2021 onwards was one change, from 2025 was the other change. That said, I think every manufacturer changed to copper-free linings first time round. But ready to go for the start of 2021, just say for R&D. So I know we did it, and I don't think any other manufacturer did it in 2 steps as well. So, but these are just some of the things that go into there. We'll get to the next slide. This is the RSD laws that we mentioned. So 1st of August 2011, it was changed from 355 feet down to 250 feet. So on a drum brake, it's extremely hard to do that. So you'll notice that steer axle brakes were the first to go. They started to up them in chamber sizes. Eventually, they all went to all truck manufacturers have pretty much gone to disc brakes because they're so much more aggressive. I will say disc brakes didn't change because the reduced stopping distance laws, disc brakes already met that. But now they went to steer axles to help with the amount of stopping distance on the steer axles, because generally they were not really doing their fair share of the work. And then eventually they decided to go to disc brakes on the drive axles as well. But then you'll notice that those laws also changed August 1, 2013, and that is for all other vehicles other than the 6x4 tractor. So you'll see 2 axles, 6x4 severe duty vehicles and tractors with 4 or more axles. They changed again to 250 feet in 2013. And the 2 odd ducks in there are the 6x4 severe duty service tractors and tractors with 4 or more axles over 85,000 pounds. They are 310 feet. Some discoloration of brake drums. So they should be like the bottom half of that photo, all shiny and silver and so forth. But when you start getting discoloration, bluing, it means it's started to see a heat cycle to go through that. So that's normally an early identifier. So go through and just check the pneumatic side and the mechanical side of the components. Make sure nothing's damaged, broken, not performing as it should. It could be driver abuse. Don't laugh. I've seen drivers do this firsthand, where they hung a Yeti, a drink bottle full of water off the trolley brake system. And of course, they dragged the trailer brakes and hooked the brakes. So little things like that can cause it. So when we say driver abuse, there's a multitude of things. We've seen drivers left foot braking, riding their foot on the brake, all sorts of things happen. And then from an extreme point of view, you go from blue to a dark black, and then you'll go to martensite spotting. Martensite spotting, as you can see on the right-hand side there, it looks like leopard print. Go through and double check. Essentially what martensite spotting is, it's little bits of friction material embedded into the drum. So you'll feel it. It's high and low spots on there as well. So generally you could machine it or clean it up, but we recommend you can see that level of heat cycle. Probably a good idea to replace the drum. When you're doing a complete brake job, if you want to burnish in and test drive the brakes, I'm not going to run through every line on that, but it will be in the presentation if you want to read it. I just want to get through to the last slides. How are we going for time? No, we're actually not doing too bad. We're pretty close. All right, the hub pilots. I will say when you're fitting a new brake drum, remember there is 2 steps on these pilots. So there's one for the drum and the big one is for the rim. Make sure the hub pilot is at 12 o'clock, whether it's a 3, 4, 5 lug pilot setup, make sure there is one at 12 o'clock and make sure that they are put on correctly. Okay, I'll show you why in a minute. So this is a hub pilot based on the whether it's a single wheel assembly or a dual wheel assembly. You can see there's a drum and then 1 or 2 rims on there as well, and where they actually sit on the pilot here. Okay. And then this one is a steer axle end with a close-up of the drum resting on a hub pilot. So it wasn't quite right, but we'll get in a little further to that. This one here, they hung the drum on the rim pilot and then thought they would just use an impact wrench to do the nuts up, hoping it would slide up. But being an aluminum rim, you can see it's just torn a chunk out of that pilot hole and ended up not going all the way home anyway. So that's a little bit of an issue that you need to look at going forward. And if you don't get it right, you'll end up with a crack in the drum, or more importantly, you can end up with two halves of a drum, which is obviously not going to do the job it's actually intended to do. I have actually seen a scenario like this before, way back when, at an OEM, that there was a clearance issue, and the trailer builder in question fitted their drums and just kept using an impact. The worker that they had just kept using an impact, thinking I wasn't home. I'll keep tightening it up until finally it went pop, and it popped that center ring out. So if you haven't quite got it home and you think there's something wrong, just pull it off and double check any clearance issues that you've got there. And if you do have any issues going forward, this is myself and my team, Ronnie, Kyle, Ben, are all super knowledgeable. We'll be able to help you out. They're all willing to help you out. There's the emails and cell phone numbers. Just keep in mind that we will help you, but sometimes we're on the trailer. So, we won't always be able to answer our phones if we're under a trailer, or we're with a customer, or we're on a plane. So if you do get in the pinch, you do also have the numbers for the group, which is below that. So for now, even though we bought Haldex a few years ago, we've got common emails. We do have separate CSR groups. So you've got the 888 number for the SAF-HOLLAND group and the 800 number for the Haldex group. And there's two separate warranty emails there for Haldex or for SAF-HOLLAND. So either way, they will be able to help you out going forward. All right, that is it that I have for everyone. Let's get to the slide. We are almost bang on time. We've got like 2 minutes left, I think. Last minute call for any questions. If you have any questions, we can certainly help you out. Type them in the chat or unmute yourself. All right. Kyle's teed one up for me and wants me to hit this one home. So Kyle's question, I'll just turn your computer around because I'm old, I need to read it. Is it recommended to reuse brake shoe hardware? Absolutely not. We recommend that you replace that every time. That's why you'll always get a brake hardware kit. Springs lose their tension, even retainer springs on rollers, they lose their tension, and the last thing you want to do is have bits coming out and causing catastrophic events. That's the last thing you want, all to save a few dollars. So we thoroughly recommend you put a hardware kit through that and don't reuse parts. Just replace them every time you do a brake job. Thank you, Kyle. Any other questions while we're here? Like I said, you can unmute yourself if you need to. No, I don't see anyone typing in the chat. So if no one's unmuted, no one's got any questions, we're pretty much bang on time anyway. If you do have any last minute questions you think of, which is always the case, we all do that, feel free, shoot us an email, a text message, call us. You've got all our contact numbers for the respective people. Ronnie's East Coast, Ben's West Coast, Kyle's down the centre. And or myself, we will certainly look after you going forward. So if no one's got any more questions, we'll let you all go. Thank you. I hope you learned some stuff, and I will send out a wrap-up email on these, and you'll get this. It'll probably be tomorrow sometime. I'll send up a wrap-up with a PDF of the presentation and a link to both the recordings. Thank you, everyone, for your time. Hope you had a good day.
So I was going to mention.
Yep.